Hello YouTube, this is Chess from STEM Welcome to another tutorial. In this tutorial, we're going to continue where we left off in the last tutorial. Or as you remember in the last tutorial, we were able to extract GPS data from an image that I took with my phone while I was on vacation. And just to remind you how we did that, we used this code in order to get the GPS information, and it was printed onto the terminal. In this case, what we're going to be doing is instead of printing it to the terminal like I have here, we're going to be printing it to the, let me show you here. Let me just run this one. So it's going to run this code, graphical user interface window, and it's going to give you the ability to click a button. Then you choose the image, you're going to load the image, and it will give you the image information, but instead of going to the terminal, it's going to the dialog window, dialog box here, and it's going to give you the same link that we got in the other one, and it's also clickable. You can click on it, and it will bring you exactly where I took that picture. Okay, so it's the same thing than the other one, but it's all done through a graphical user interface. So that's what we're going to be doing, and the way we're going to be doing that is by using the FLTK library. For those of you that are not familiar with FLTK, I did a tutorial series this, as you can see here, a few years ago. I did two playlists on dealing with FLTK and using OpenCV, using all kinds of stuff. For those of you who don't know, FLTK is a C++ library, as you can see is here, but they have bindings that work very well with Rust. And it's this one right here, and that's what we'll be bringing in. I mean, it works very well. I mean, it doesn't work with all images, but for those images that it doesn't work well with, what we're going to do is keep working with the image crate that we've been using all along. Okay, so let's get started. Just to give you an idea of how Rust works, it's very easy to use. For example, this is just so you see it. It's a very simple load image file. We open it and let's Command B, save it, run it, and now, oh, I didn't stop that one. So let's do it now. Command S, run it, and it opens the image. That's all it does. But as you can see, the image does not scale. When you open the window, it kind of stays the same height and width. Okay, so what we're going to do is change it a little bit. So just to give you another idea how easy it is and how flexible it is, let me go here and this is basically the same code, but instead of being fixed, I'm going to be running it. It's the same thing. The only thing it has this that is going to scale. And so you save it and now run it. And now when I open, as you can see, it grows with the frame. Okay, so it's a very, it's a great library, very lightweight, very easy to use, and like I said, it has that bindings with Rust, so that's why we're integrating it. I mean, you have other options out there. For those of you that may not know, you also have this is some of the ones that are out there. You have FLTK, but then the C++, but you have 3JS, which is JavaScript, Electron JavaScript, Qt, C++, and Unity, of course, C Sharp and C++. And some of them, this one works great with Rust. That's what I'm using FLTK, and also because it's efficient and lightweight. Okay. So that's why I'm using it, and cancel, and let's get out of here. So now let's get into the main code here. It's this guy, and it's a long snippet, but a lot of it is just copy and pasted from the last video. A lot of it is just GPS stuff, and let's just overwrite this one. Command B. And now let's talk about the code because there's a lot of stuff going on here. Like I said, a lot of this stuff is you've seen in my last video, but this is new. This is where I'm bringing FLTK, and I'm bringing it from. This is the cargo toml. Don't worry about all of that stuff. Just worry about the image, that crate that we've been using. Chrono, you need that one. TIFF, you need that one. You need exif for the metadata, and the FLTK crate, of course. That's the main one. And open32, you might need it. I believe you need it in this one, just in case. But that's all you need to add to your cargo toml file in order to, so you are able to bring all of this stuff. The app, this is just the app button. This is basically look at it as managing the overall graphical user interface application. These are the buttons. We have the two buttons that I show you. This is where that's coming from. The frame, I just saw you. That's the one that populates the image. Group, you're gonna use this for the toolbar and for the scroll bars. I image RGB image. Just think of it as making the RGB image data in a full tick compatible format. That's the easiest way for me to explain it. Window is just the main window that is going to be housing all of the widgets. Prelude, don't worry about it right now. File dialog, okay, enums, this is for the bit color depth. Is it 8-bit? Is it 16-bit? RC, this is the reference counting. These two guys work together. Beyond the scope of this tutorial, think of it as uh, reference counting for share ownership. That's the easiest way to explain that. This is the file paths, the path of the files, the file system from the standard library, input output from the standard library. Image, we need the image because we'll be using some stuff that FLTK it does not do very well with it. So that's why we're using. And exif, of course, that's the stuff that I show you from the Kamada exif. And here, this is where we're getting the fractions, the rationals for all of the tag data that we are using to tag the images and let us know what's going on with the GPS metadata. Here, this is where we're make the reference to ASCII code to make it human readable, to make everything look so we as humans can make sense of it in a human readable format. Here we're doing the GPS altitude and GS. Where's the other one? GPS altitude and here it is. GPSA altitude and GPSA altitude ref and altitude. The ref indicates whether the altitude is above sea level or below sea level, and the GPS altitude is just a rational value representing the altitude. We continue. This is the timestamp to let you know where it happened. Um, it's getting the rational that I from before, the fractions. Here is giving you the hour, the minute, and the second. Here is giving you the date stamp, also in a human readable format of date, hour, minute, and second. And that's what you see. Converting to decimal degrees. That's we did that in the last tutorial. It's just it's easier to use when you're mapping it with everything else. Uh, it's adjusting. This is if it's north or if it's south and west is gonna make it negative. Yeah, as opposed to north and east. Okay. Here, this is where we're working with the TIFF files and we're bringing the image crate, and this is what's happening here. And here is the file sizes. Is it a megabyte? Is it a kilobyte? Is it this is what's happening here when we get the metadata for the file sizes. Here is the chrono stuff. It's just the time. We're using the chrono third-party library. Here are all the GPS information. This is where everything just gets linked to the Google Maps and all that, and to the link that you can click, bring in the latitude and the longitude. And here the format for the more additional information of what the type that is using is what kind. Is it a TIFF, is it a JPEG, and so on. And here is the graphical user interface stuff. Here is basically the window. Is it a 800 by 600? Title of the image. The toolbar is a group. The two buttons, as you can see, they're the same size, 5 height, but they're about 100 pixels away from each other. So this one's, as you can see, it starts X, Y, X, Y, but they're the same size. This is the title of the button for both buttons. And that's where the toolbar ends. And now here we're doing, that's the frame that is showing, bringing all this stuff. This is the reference counting that what I mentioned before, working with the ref cell. And that's what I meant by the mutability and all of that good stuff. Here is just working with the what type of image is it, and the scaling. This is where it's going to scale up and there up to the limit, meaning the maximum width, maximum height. And then what else? What else? These are the buttons. These are the callbacks. This is the info button callback, and this is the open button callback, and the scaling, the info button with all the information, and that's the end. And that's basically what is happening. Now let's run it now on this one. Control C, let's clear it. And cargo run, we don't need a name because it's gonna work with everything. Actually, I didn't save it, that's why. And now, if I run it, it's going to create the same one that I showed you before. So it will open an image. Let's open a different one this time. And we'll open it. And we'll give you the image information. So you can see all the metadata. And now we're gonna click on it. and it's going to bring me where I took that image, which it was in New York City um, last year, a few months ago. And if you did everything right, if you brought the dependencies, you could do this to an image that you took as well. And I'm gonna put everything here that you see here in my GitHub page, and you're able to go there and use the code for whatever you want. But this is the end of this tutorial. If you like this tutorial, click the like box and subscribe to my channel. In the next tutorial, we're going to be populating that toolbar with other buttons that are going to make our life easier as we keep working on our image viewer. But I'll see you in the next tutorial. Take care.